Alright, for concentration, we are going to look to see how much solute is dissolved into a certain amount of solvent. When we look to see how much solute is dissolved into a certain amount of solvent, sometimes you can just look at it and see by color. So this one, you can definitely tell is red. This one is just barely pink. They have the same thing in it, which is just food dye today. But this has a lot more red food coloring than this one. So when we think about concentration, this one is a lot more concentrated than this one. In chemistry, though, dealing with a lot of white powders and clear liquids. When we deal with a lot of white powders and clear liquids, you can't usually see the difference in the concentrations. So if you have a number that's attached to it, because in chemistry we like numbers, something like 3 big M, that's molarity, that's a way of mathematically figuring out what is the concentration of the liquid that we're dealing with. So if it's hydrochloric acid, we would say that it's 3 molar HCl. The 3 just tells us how much hydrochloric acid is dissolved into water. Usually we use water for your solvent for chemistry. So back to this concentration one, you can have more concentrated things and you can have less concentrated things. With your more and less concentrated things, if you have orange juice, for example, frozen orange juice that comes in a little can is concentrated orange juice. That means that they take the water and they evaporate it away. When you add that to water, you dilute it down. The concentration is a lot less because there's a lot more water there. So we have more concentrated and less concentrated things. Molarity gives us a number associated with it. So the 3 is a lot stronger than the 0.001 molar. And both of them are hydrochloric acid. It just has to do with how much solute is dissolved into a certain amount of solvent. Molarity is usually just called big M, capital M, because the unit is a capital M. So here I wrote a capital M, here I wrote a capital M. You have to be very careful when you're writing these because we're also going to have something here in a little bit called molality, and that's a lowercase m. So you have big M and you have little m. The equation that you're going to use for your molarity problems to figure out how concentrated something is you're going to take your moles of solute divided by your liters of solvent. The faster way of writing this equation is moles of solute divided by liters of solvent. If you liked the triangles that were used, big M is equal to your moles of solute divided by liters of solvent. So with your molarity, we're going to solve, and when we solve for these, we're going to get an answer. Your answer is just big M. It'll just tell us what is the concentration. The larger the number, the more concentrated it is, or how there's more solute there. The lower the number, there's less solute in your solvent. So the unit that we're going to use for your molarity is just a capital M. So you might have like 3M, or you might have 0.125 M. You can also write that down instead of, if you wanted to do this, moles per liter. It's the same thing. Most people just do the big M though. So molarity actually means how much solute do we add to a certain amount of solvent. You're currently watching the YouTube video, so you don't need to worry about that link. So when we have these problems, it says a student dissolves 2.75 grams of sodium hydroxide in water to make 250 milliliters of solution. We know that we need our moles of solute divided by liters of solvent. So when you're looking at the wording here, it says the sodium hydroxide is dissolved into water. So because the sodium hydroxide is dissolved into water, your sodium hydroxide is your solute, your water is your solvent. So this number, your grams, we're going to have to turn into moles. To go from grams to moles, we need to remember the conversion factor. 1 mole is equal to your molar mass in grams. We're going to fill in that blank there with the formula for sodium hydroxide, which is NaOH. So we're going to take 22.99 plus 16 plus 1.01. That gives us 40 grams for a molar mass. So our first step, we need to take our grams and turn it into moles. 2.75 grams of NaOH. To get rid of grams, grams has to go in the bottom. Molar mass is 40. That's equal to 1 mole. So 2.75 divided by 40. We have 3 sig figs here, so I need 3 sig figs in my answer. 0.0688 moles. So then what we're going to do is we're going to take our solvent, the 250 milliliters, and turn it into liters. Before, I have 2 sig figs, so I'm going to move my decimal place 1, 2, 3 times, drop in my new decimal, so you get 0.25 liters. So now I have moles and I have liters. I can plug it into my equation. 0.0688 divided by 0.25. We get 3 sig figs, 2 sig figs, 2 sig figs, and my answer is 0.28. The unit is big M. So overall, the problems are very easy to solve. The biggest part is you're going to have to convert moles to grams. Or I'm sorry, grams to moles. Do that backwards. And then sometimes you're going to have to convert your milliliters to liters. Otherwise, it's just plugging into the equation, moles divided by liters, and that'll give you your answer. So if we look at the second practice problem, it says that we need 1.75 liters of a 3 molar sodium hydroxide solution. How many grams of sodium hydroxide do you need? This is most similar to what I do whenever I'm preparing the solutions that we use in chemistry lab. I know mathematically I need 1.75 liters in order for everybody to do the lab. It needs to be a 3 molar solution in order to react properly. So I'll need to figure out how many grams of sodium hydroxide I need to add to the water in order to make the solution. Now when it says that we have 1.75 liters, that's assuming that you have 1.75 liters of water. So this is my solvent. I know my big M. So if we go back to the triangle, big M is equal to moles over liters. I don't know grams, but I have moles here. So what we're going to do is we're first going to solve for moles. To solve for moles, we cover that one up, and we're going to take our big M times our liters to get our answer. So we have 1.75 times 3. When we take 1.75 times 3, you get 5.25. The unit for this is moles. Now we have moles, we need grams because that's what the question asks for. To go from moles to grams, again, we're going to use our molar mass. 5.25 moles. 1 mole goes in the bottom. We luckily found the molar mass of sodium hydroxide in this last problem. It was 40 grams. So sodium plus oxygen plus hydrogen. So here we're going to take 5.25 times 40. I had 3 sig figs before. I need 3 sig figs in my answer. So 210 grams of sodium hydroxide is what it takes to make 1.75 liters of a 3 molar sodium hydroxide solution. So that's one type of math problem that we're going to do with your concentration. The other one we don't use very often, but we're going to use these in our freezing point, depression, and boiling point elevation equations, so we have to use something called little m. Little m is molality. For your molality, it's just another way of figuring out how concentrated something is. But with this one, it's how many moles of solute is in a given amount of kilograms of solvent instead of liters. So you end up with a similar equation that your molality, little m, is equal to moles of solute divided by kilograms of solvent. So with your little m is equal to moles over kilograms, we can also use the little triangle again. Little m is equal to moles of solute divided by kilograms of solvent. Your unit ends up just a lowercase m, not a capital M. That was molality. I'm sorry, molarity. Molality is little m. or you can write it down as moles per kilogram. So this is where you need to be very careful when you're writing your answers. I need to be able to tell the difference between your capital M and your lowercase m. Some people like to underline the capital M just so you know the difference. That's totally fine with me as well. But capital M versus lowercase m, make sure I can tell the difference. So with these practice problems, we have a couple of them again. They're in the back of your notes. It says you have 4 grams of sugar dissolved into 342.11 grams of water. What is the molality of the solution? So we need to take our moles of solute divided by our kilograms of solvent. It says that we have 4 grams of sugar dissolved into water. So the sugar gets dissolved into water. So sugar is your solute. Water is your solvent. You can also look at it as you have less solute, you always have more solvent. So this smaller number, your 4 grams, is going to need to go to moles. To go from grams to moles, we're going to find the molar mass of this guy right here, C12H22O11. So we're going to take 12 times 12.01 plus, let's see, 22.22 is your hydrogen, plus 11 times 16. So the molar mass of sugar, 342.34 grams, is the mass of 1 mole. So 4 divided by that, that answer, with 1 sig fig is 0.01 moles. Now this number right here needs to go to kilograms. So King Henry died by drinking chocolate milk. I currently have base, so I'm going to go 1, 2, 3 places again, just like milliliters to liters. So we have 342.11, 1, 2, 3 times, drop in my decimal. So you end up with 0.34211, and that is kilograms. So now I take my moles, divided by my kilograms, and we'll get an answer. 0.01 divided by 0.34211. With 1 sig fig, you get 0.03 little m. So same general process. The only difference here is you're going to take your bigger number. Instead of going to liters, you're going to go to kilograms. The second practice problem, it says how many grams of potassium iodide is Ki, must be dissolved into 500 grams of water to produce a 0.060 molal Ki solution. So that's little m. So that means that they give us, let's see, it says the potassium iodide is dissolved into water. So they're giving us the solvent. This needs to go to kilograms. And then this right here, when we solve for it, they're going to give us moles for our equation, and then we're going to have to convert it. So if we go back to the triangle, little m is equal to moles of solute divided by kilograms of solvent. They're giving me little m. They're giving me the number that needs to go to kilograms. So we're going to solve for this guy right here. So you're going to take your little m times kg. So your little m, 0.060, times your kilograms, go 1, 2, 3 times, 0.5000, 0.06 times 0.5. This has 2 sig figs, 4 sig figs, so 2 sig figs in my answer. That's moles. So now I can take my moles and convert it to grams by using the molar mass of your Ki. So 126.90 is the mass of iodine, plus 39.10. You get a molar mass, 166 grams. So 0.030 moles. Converting your moles to grams, you're going to use that molar mass that I just found. 1 mole is equal to 166.00 grams. So times 0.03, 4.98. We need 2 sig figs in our answer, so that's going to end up at 5.0. We are solving for grams, So it's going to be 5 grams dissolved in. So these take a little bit more because you have to convert your moles back to grams, but it's basically just backwards from what we did. So there's 2 equations that you're going to need to know for this test. You're going to need to know your big M and your little m. So for your big M equation, you have your moles of solute divided by liters of solvent. For your little m equation, you're going to take your moles of solute divided by kilograms of solvent. And it'll tell you which one you need to do. The solvent is always on the bottom. The solute is always on top.